Hi there. I'm not Sam Tucker, but here at Maker's Corner, we've been very busy lately innovating, pushing the bounds of what is possible when it comes to, well, useless technology. And today, I'm excited to share with you the all-new, I actually don't have a name for it. It's a useless button, it's a meme button, a sound button, I don't know. It's a button, you push it.
Lizard.
And it plays a sound clip of your choice. I don't know, you guys come up with a name for it. It is USB-C rechargeable, and the battery does last quite a while. In fact, I charged this thing up about 3 weeks ago, and, well,
Lizard.
as you can see, it's still working just fine. So, if you want to make your own, let's get started. God, I can't believe this is what we're actually making today. We really need a bigger budget. So, as per usual, you will find all the files needed for this project down in the video description, and while a few of these parts do require a multi-material capable printer, I will also be including some alternative files for those of you without multi-material capabilities, should you decide you want to still make this silly little project. Alright, so with all the printed parts complete, we can now add our heat set inserts to our main body. We're using M3 heat set inserts here, and as you can see, I made a little bit of a boo-boo. I did not make the holes the correct size, so I'm having to use a piece of scrap metal to push the sides back down because they kind of bulged up a little bit. Don't worry, this will be fixed in the version that you download. Once we have the ones from the bottom installed, we can flip it over and do the same thing for the top. And again, it's the exact same process. 4 M3 heat set inserts, and then we can move on to removing the supports from our button and our bottom grille. Now, this is an area where a multi-material printer is almost a must, because without using PETG as a support interface material, removing these supports would be, well, let's just say not very fun. And I'm going to show you guys how to do that here now. So in your slicer, whether you are using Bamboo Studio or Orca Slicer, the process is going to be the same. I'll leave this paused on the screen here for just a moment so you can see the settings I'm using. We're using PLA as our main material and PETG as our support interface material. If you're using Bamboo Studio, once you select PETG as your support interface material, it will automatically change all these settings for you. However, there is still one setting we do need to change ourselves, and that is the top interface layers. We want to use at least 3 or 4 layers for this. This will make removing the supports significantly easier. And if you look at the print preview window in the center of the screen, you'll see our part. I've got it sliced about halfway down here just to show you guys the green is our PLA and the black is our PETG, which means everything above that will be printed on the PETG, and because PLA and PETG do not bond together, these supports should pop off very cleanly. With the 3D printing stuff out of the way, let's move on to electronics. Now, of course, there'll be a download link in the description for you to get these files, and the important thing to keep in mind is that the file structure needs to stay the same. The data folder is where our audio clip lives, and there will be instructions on the GitHub page explaining exactly how to prepare your audio file for upload. Once you've got your audio file in there, simply open up the sketch, upload it to your ESP32, and then using LittleFS, transfer your audio file over as well. Now, this tutorial does assume that you know how to use Arduino IDE and LittleFS, but if you do not know how to use LittleFS, I will leave a link down in the description to a fantastic tutorial that'll get you up and running in no time. Alright, so now we can move on to preparing our amplifier board, which will be connected to our ESP32. I'll show a quick wiring diagram here to explain how everything is connected, but for the most part it is very straightforward. The only weird thing is we are going to have to solder 2 wires to the ground pin on the amplifier. Once that's done, we can flip it around and solder our 2 wires for our positive and negative for our speaker. I'll then bend up the excess wire and with a pair of flush cutters snip them off just to clean things up a little bit and keep things nice and tidy so nothing shorts out. We can then move on to connecting our speaker, make sure positive goes to positive and negative goes to negative. Now, if you accidentally get them mixed up, it's honestly not the end of the world, but the right way is to make sure that the polarity is correct. To make life significantly easier on myself, I'm now going to connect the battery to our ESP32 before we hook up our amplifier board. Otherwise, you're going to have a mess of wires, and trying to get in there and solder these tiny little connections is not going to be fun. Once our battery's been soldered to the ESP32, we can now start connecting our amplifier board to the ESP32, and yes, I'm aware my camera work here is pretty awful, hand kept getting in the way, but that's okay. Like I said, there's going to be a wiring diagram to explain everything, because that's going to be way easier than me trying to say, okay, plug this into here, plug this into here. Wiring diagrams for the win. We can now start shoving all of our electronics into the enclosure. I fed everything up through the bottom, and then I took the speaker and I just loosely pressed it into the bottom cover. This is a pretty snug fit, so it should stay on its own more or less until we can grab our hot glue gun and run a bead around the very bottom edge just to secure it in place so it cannot come loose. You don't need to go crazy with the hot glue, just a small bead is more than enough. I'm now going to flip things around and just do a quick test fit with the ESP32 to make sure that its USB port lines up with the hole in the side of the enclosure, and once I'm happy that it does in fact line up the way it should, I'll again use a little bit of hot glue to secure that in place, and then I will secure the amplifier board on the other side again using some hot glue. Once everything's been put together, I will take our 2 wires for our switch and touch them together.
Lizard.
And there we go.
Lizard.
She works.
Lizard.
Now that we've confirmed everything is working, we can flip everything over, and using some M3 bolts, we can close our bottom lid up and move on to the next step. So let's grab our top lid and push our momentary switch into it. It is a bit of a snug fit, so you may have to put a little bit of force on it. I then took the nut, put it over, and tightened it down using a pair of pliers. We can then move on to connecting our last 2 remaining wires to our momentary switch. Polarity does not matter, so solder whichever wire to whichever side of the momentary switch you want. Once everything's been connected, I will push that button a few times to make sure everything's working as expected.
Lizard. Lizard. Lizard.
Alright, fantastic. Everything seems to be in good working order, so I'm going to just take all these wires and shove them inside there as best I can, pop the lid on top, and then making sure that our through holes line up with our threaded holes. We'll then take some M3 screws and secure that in place, and then we can move on to the second to last step before this project is complete. It's time to add our springs. So for this, I used some 2-part epoxy, mixed it up really well, and then just drizzled a very small amount into some of these counterboard holes. Now there are 8 holes, you don't need to use all 8 of them. You'll see in this video I actually only used 6 springs, but you can use 4 if you'd like. Regardless of how many you decide to use, just remember 4 is the minimum, and you want to make sure that they are evenly spaced. After giving the epoxy some time to cure, we'll move on to the big button. Now, one thing you are going to notice is that the button here has a white disc in the middle. Yours will not have that. I made a mistake, and it's all fixed in the final version that you guys will be downloading. Just make sure that you only drizzle some epoxy into the same exact counterboard holes as what you did on the main body. After that, we will just very carefully line everything up. It actually goes in quite easily. I made sure there was enough tolerance there for some wiggle room. And I just give it a nice little press down and maybe a little bit of a wiggle just to make sure all the epoxy's worked its way in. And then the final step before this project is officially complete is to add the bottom grill cover and feet. Now, depending on how well your printer tolerances are, this may just snap in, and it may not. If it doesn't, you can use a little bit of hot glue to secure it in place, making sure that the alignment pins are properly aligned before pushing it down. Now the last thing I do is to test it out and see if it works.
Lizard. Lizard. Lizard.
And as you can see, our quote-unquote useless button or meme button or whatever you want to call it works just great. Now, one final announcement before we end this video. I will be attending Rocky Mountain Rep Festival this year, so if you happen to see me there, feel free to stop and say hi. I look forward to meeting as many of you as I possibly can. But that's going to do it for today's video. I hope you guys enjoyed. I know it was a bit of a silly video, but it was still a fun little project, and I've got so many more in the works, so I look forward to seeing you guys next time. Until then, like and share the video, and of course, don't forget to subscribe so you don't miss the next video.